We kind of did this last year, and I thought it worked pretty good. And so we asked the panelists to prepare a little bit that said, if you could go back in time a year and talk to yourself a year ago, Tommy probably would have said he would have retired a year ago. But the rest of us, we said, what would you tell yourself? What was a big lesson that you learned this year, that you would tell yourself from a prior year? And I was going to kick it off. In 23, we videotaped this session. I couldn't find the one from last year, but I kicked off with some of the comments. But the funny thing was how certain I was, bullet 6, that no, we were never going to get to more than 120 kilowatts, in a rack, and that's what the number came from, 2,500 watts per U. And the reality is, I'm going to show you some things that today were 3 times that level. And you might pay attention at GTC in a month and hear something else. But we're already, just kind of blowing through the power level that we're seeing, because they're just the performance per watt, performance per dollar is great. Tommy, thank you for all your years of service for the industry, and especially for this conference. And I think we're going to invite you back next year to give us best practices in retirement. So when we do leave, we don't come back.
I'm hoping I won't fail like Keith, though.
Yeah, Keith retiring a few times.
Although Dan is encouraging it to, he wants me to fail.
So I think the one comment I wanted to ask you that I was waiting till you came up. I'm glad you talked about the ZutaCore and the Childyne, but what about weight? Especially with your raised floor environment, any guidance for the people here that says if you had to do anything special to support the floor? I know we're not in a seismic region in Texas, so we're not as worried about trying to get those plates to fasten to the floor. But any lessons as you've deployed, and especially as you're thinking about Horizon? I'm assuming you thought about that before you retired. Your system at Saby there. Things that you're doing to support the weight as racks are getting more power and thus heavier.
Right. Now, the thing is it's our storage racks, our old, I have to say, our older storage racks where they had spinning drives in it were still the heaviest racks we ever deployed. We haven't had any special considerations. They are still designing for 2,000 pounds per floor tile in Saby. And even with the liquid cooling, it's not adding a whole lot of capacity per rack. Keep in mind, though, the racks are getting wider. That's kind of the trade-off we're doing now. Instead of having the standard 24-inch wide racks, we're going to have 30-inch wide racks. So they are going to span a little bit more tiles, and so there'll be a few more, and they're going to be deeper. Heck, even on Frontera, our racks are 5.5 feet deep. I think for Horizon, they're going to be over 6 feet deep with a rear door heat exchanger. The racks are going to be designed for about a couple hundred kilowatts a rack with room neutral as well. So
were you probably 3,500 pounds a rack before, maybe pushing 5,000?
We were somewhere in a little less than that. I think our racks were around about 3,000 pounds.
And even as racks get wider, are you feeling like that's enough, 3,500 pounds?
I think we're still okay with the that level. And the main concern I have really is kind of rolling the racks around, and we do use kind of our own. We bought some custom rack rollers that we have that much bigger wheels and better can maneuver around the room and get over the lips and stuff and get in the data center. So when we're moving stuff around, we're using the rack movers to do that, and that helps spread again some of the load out across more of the tiles.
And do you ever? Other question I want to say was, do you ever disconnect a rack from the secondary fluid network? Is that something you find that you need to do for?
Yeah, absolutely. We've had to do cooling manifold replacements. When Cool IT, again, we were one of the early adopters of the new cooling manifolds from Cool IT, and that we found debris, actually metal filings in a bunch of them, and it's caused the metal filings get in the quick disconnects, and the quick disconnects will start dripping. In some cases, they've just Cool IT's decided to replace the entire manifold. So absolutely, being able to cut the rack off, being able to get all of that, and again, it's a another quick disconnect at the rack level. It's one of the big 1.5-inch quick disconnects. So they take some muscle to really reconnect them, but absolutely want to have each rack individual connected so you can cut it off and continue to work on it if you need to.
Okay.
It's going to be interesting. I know for the Horizon design, we're actually going to have 3 different connections to our secondary cooling loop. There'll be one on one side of the rack for one manifold, one on the other side of the rack for the other manifold, and then another chilled water connection. Not a chilled water, but a secondary cooling connection for the rear door heat exchanger.
Is there specs of that system on your website or the release?
I don't think we've released them yet. Dell did release the rack specs at SE last year. I think they've announced that rack that we're going to be using. And in fact, I think they've already got some deployments of it going on right now with, in fact, MVL 72 deployments that I think just got recently announced.
We'll look forward to your replacement, if that's such a thing, to come show us that system next year.
Dan's working on it.
Okay, thank you. Kent, I think you were up there.
Okay, most of the stuff we did this year worked fine in the existing data center. Did CentOS to Rocky 8 upgrades. Our big one was Grid Engine to Slurm transition. We, at the very end of the year, received our first reasonably sized GPU cluster. It's a 40-node, 8-way GPU box. So it's working out well. It's already completely pegged with seismic applications. AI is still a tiny little fraction of what we do. We are still very enamored with DLC. We're getting pushed, like several of our friends up here, to try immersion cooling with our own sauce.
Donnie, do you guys make a sauce as well for immersion?
Of course we do.
Of course you do. I know those guys.
Yep. We still see too many issues with that. We're trying to look at a cluster for that and talking with the vendors about support. What's the warranty? And it is very different than air-cooled or DLC systems. So that's something you have to think about.
So you're just getting more pressure this year to go adopt to it.
Yeah.
Okay.
But when you turn around and say, so you, the liquid vendor, are you going to warrant the machine? That kind of stops most of the questions because they're not going to do that. So
Jeremy, you going to warrant immersion, or Bill, you going to warrant? You get different nods from different fluid vendors. Great.
Really?
They can talk out.
Well, we've talked about mergers too, so it comes up every.
Well, and we didn't have the requests weren't coming specifically for us to consume the fluid, but just to validate it because they want to have a fluid that's qualified for use even in telco and other systems. I mean, of course, we qualify fluids for battery cooling and things.
Mm-hmm.
But yeah, in immersion, they're just looking to have a qualified fluid to be included in the vendor list of whoever's going to dunk things in fluid.
Yeah, and that's where we are too, in doing a lot of fluid qualifications. I have a bullet on immersion too, and I don't want to exit this slide here, but we do have.
Jeremy is ExxonMobil.
That's right.
Bill
Are
is
we gonna
Shell.
intro?
Donnie's Total. They didn't introduce.
I wore my shirt.
We let everybody
we can
talk
intro.
themselves, in their each
Yeah.
section, but we kind of interactive up here.
We're in the middle of a reorg, but based on everything we're hearing, it's better to be in HPC than other parts of IT. So we're getting lots of good support from our user management all the way up to the executives. So that's good to know. HPC is still going to be around and going to be very important to the businesses. We did spend the last 2 years doing conversions of GPU applications or applications to GPUs, and our 2 biggest applications are RTM and FWI. And
FWI for the uninitiated?
full waveform inversion,
Okay, which is used for?
seismic imaging.
Okay.
And AI is all the buzz in the industry, but it's not so much in what we do. We're still a physics-based environment. Everything we deal with, almost everything is physics-based. We have equations to solve for the known.
And is it the full precision for solving the Navier-Stokes across continuity, momentum?
Green's functions
Okay.
are different equations, but they're known to be correct. We've had to approximate them for so many years, and we're getting closer and closer to being able to do the full equations.
With the full precision.
Yeah, people like to talk about 64-bit floating point, but we're actually doing most of it in 32-bit. So we're probably not getting all the benefit of the fancy whiz-bang GPU features, but we can still take advantage of them. It's still accelerating faster than CPUs.
I think I asked you this before, and with Tommy was on, he was talking about people hitting they were hitting the Grace hard, but they weren't hitting the GPU hard. And I think that, when you look at your H100, oh, by the way, that's the motherboard for the H100.
I need that shirt.
On my back.
It's awesome.
There. Yeah, that's one of the layers. I don't know which layer that is. But if you look at, some of the specifications, our own branded one, air-cooled, is like 10 kilowatts. I don't know what the Dell or HP Lenovo Supermicro is, but I think you said you found that with the Lenovo liquid cooling, you're hitting at about 7 kilowatts?
7,500 watts is the max we can push it.
Do you find certain codes are hitting it harder? Or,
Well, that's either RTM or FWI, and it can just saturate the GPU.
And that's still south of 8 kilowatts?
Right, in DLC.
Okay.
Whereas the air-cooled system was right at 10 kilowatts.
Okay. So the difference was the fan power alone?
Yeah.
Okay. Not a ML perf run or
No.
something that was trying to super saturate it.
That's all we can get out of an HPL or anything else on the same box.
We found we use FWI for burn-ins even on CPUs to
Yeah.
pull more thermals out than HPL did.
Yeah, a lot of times. Okay. So
And I think it was Donnie that mentioned these are such expensive resources, we're having to watch them more closely and make sure if you're allocated a GPU, you better be using it. And we're doing a lot of that now.
So your applications hit it as harder than a synthetic benchmark, HPL or otherwise, and it's 7 kilowatts of DLC and 10 kilowatts of air.
So we could have gotten some more machines if we had, Lenovo couldn't tell us what the actual max on.
And I
series
bet
would be.
it's more than that, Delta, because you could probably go dry cooler and compressorless as well. So not only do you save the 3 kilowatts there, you save that same fan energy at your fan wall, you save that same compressor energy. I don't sell liquid for a living. I'm just making a point here that
We appreciate it.
yeah, you guys all sell PG-25 now, right? Okay, thank you. And we got plenty of time for keep questions going. Oh, you had another slide there, sorry.
Okay, yeah, seismic still rules the world. Cloud, there's lots of investigation going on with AI, and most of it, it's research, so there are going to be lots of failures. We've had a few little successes, but it's still a case where seismic is 85% of what we do. Budget cycles with some of the supply chain issues, annual budget cycles are a problem. If you don't order stuff at the beginning of the year, you're not going to get it for the budget.
You guys thought about leasing computers?
Yeah.
That's a good way of managing the costs.
Yeah, I know.
Having it attributed to the appropriate year to be much more flexible.
I've heard HPE does that. Wants to lease you computers. I've heard
Do
that.
you know anyone that does that, Keith?
Oh, yeah, he is. Yeah, it's something we may have to push back on management. They had a big transition since you left about converting to purchasing instead of leasing. This may be a good reason to push back. But the issues about supply side or supply chain issues, you need to think about everything you're going to need. Substation, medium voltage switchgear, room PDUs, rack PDUs, everything is hard to get. They are 9 months for some of those things, a year and a half for switchgears, parts.
Well, maybe with the government funding drying up for Tommy Attack, maybe you'll get, if they don't have any money anymore, maybe you'll be able to get better in line with that equipment.
I don't think the government's buying all of it. It's the social media.
It's the hyperscalers.
AI companies. And the cloud providers always want us to come out and try their stuff, but they want reservations. And they've got to pay for what they're buying. Quit buying it, and we'll just buy it and use it. They just want to put a hefty profit on top of it.
Shame on them.
Yeah. Communicate your long-term strategy with upper management, because there are cases where they will come back and say, can you accelerate that? Which is always a fun problem. That's what I've got.
Okay, thank you. All right, I think, Jeremy, I think we put you up.
Am I up next?
Yeah,
Okay.
and we put you up next.
I'm definitely going to pale in comparison to your double animated multi-bullet point slides. I wish I would have saw those before I published. I think I was the first to go in. But the 3 bullets really does help with the lawyers. So now I don't, I can maybe.
You can ad lib after this.
There
It
you
is
go.
being recorded, though.
So I
What
did
about the
notice that.
co-pilot?
Yeah, I noticed that it's very much being recorded, so I will definitely make sure I'm aware of that. So just kind of kicking off on the top here. So I have a section really about, so I took this, you said facilities learnings. I really enjoyed what you brought, which was maybe a wider perspective of what you guys did, and happy to answer questions on that as well. But over the last year, we've been kind of shopping for a device that can handle some of our seismic needs, very similar needs that to what Kent mentioned, and we learned a lot about that. We shopped across a lot of the various options on a premise, in another premise, some sort of leasing models, all kinds of options. And the big one that we learned around after we kind of made a decision, which is going to be subject to some media in the future here, so I'm not going to really talk about that, but was around optimizing an on-premise power structure, a power availability, which is what I'll call temporarily time and financial bound, but not forever bound. Kent made some good points about how long it takes to get transformers, PDUs, things of that nature, and that can be a massive issue. And so you really want the learning for me that I guess we relearned a little, but the learning for me was really how to get the most out of a power bound location, right? And so for us, touching on a lot of topics that folks on the panel mentioned, our codes don't fully saturate a GPU, all the cores, right? All the tensor cores and the non-FP32. So FP32 is something that we're quite fond of, and we find that a GPU, let's say it has a 750, 800 watt cap per GPU, and I may need to look at some of the numbers there. It may use less, 2/3 of that as just a rough example. And as we specified prior systems, and you work with facilities folks and electricians and plumbers, and everyone's got a margin of safety, that kind of breakers and power supplies, and everyone's got that 10%. You add it up, and then you look at the GPU, and you're not using all the transistors, et cetera, on that. Now you've got let's call it a megawatt nameplate machine that burns significantly less than that, yet in your mind, all the power in the room is allocated, right? So for us, one big learning with this acquisition is around, intelligent use of power caps, understanding your algorithm. Now we are blessed to very much understand our algorithm and almost have a single purpose machine. Some people would love me to say that. Of course, that's never the case, but really blessed to understand what's running there, how it will be running, what our outcomes are, success criteria, et cetera. And so one, if they understand that, they maybe can over provision or provision it intelligently to utilize all the power. So if you have and I'm working with, let's call it high single digit megawatts in a temporary time and financial time bound scenario. And if I can get 50% more on a 1 megawatt machine like Discovery 5 that's been published, it's currently number 46 on the top 500. And when it unveiled, it was, I think, number 16 on the green 500. And that's been changed a lot now because I guess the top green 500 machines are like 67 kilowatts. How is that even an HPC? I don't understand, but that's a different point. Thanks, Copilot, for recording that. Anyway, the point is if we were to optimize it at that point at the green 500, I think it would be a lot different in terms of what it can do, but maybe not on the green 500 benchmark, but on the ability to run profitable compute cycles benchmark. Because for us, the more I can get out of a GPU, the more speed to market I get, the better quality decisions, the higher integrity images, et cetera.
Performance is still king, and while performance per watt, obviously we care about, but
Yes.
it's performance.
And that's a little bit on
business
my,
results.
efficiency. This is the third bullet here is, and I'll just jump to it quickly since you mentioned, but it's the whole package. We gave a talk earlier this week around our benchmarking process and how we really look at different systems. But I mean, obviously, if everything matters, the power, the footprint, the dollars, but at the end of the day, time as well, speed to market, the ability to get gear on the ground, especially if in a scenario where you're in either waiting for gear to arrive or waiting for a budget cycle, and the market doesn't wait for budget cycles. So, but at the same time, you don't want to buy something that doesn't work for you long term, because I am bound with like 5-year amortization cycles, and I like to buy stuff and run it really hard, and that may be a cultural thing. So there's other influences.
On your second bullet, now,
Yes.
your Discovery system is a big Cray EX
That's right.
Shasta
That's right.
system, so no fans at all.
That's correct. Yep.
As you compare, have you compared that to immersion? I mean, one of the value props of immersion is, I can use warmest dry cooler water, but in a system that's 100% fanless. Is there a
And that's
benefit?
the jury is out on that, and I'm really interested. You mentioned the difference in consumption between an air-cooled 8-way and a DLC, and I'm interested in those multi-thousand watts. Maybe they're just moving and we're not seeing it. I don't know. I'd be interested to see. So I don't actually know the specific PUE deltas, apples to apples, on a tank that's got the same amount of, let's just say, capital and cooling grade equipment versus a DLC fanless system. That's to me very interesting. Testing that is probably kind of expensive.
I'm sure your marketing arms
working
want
through
you to
that.
do that.
Yeah. Oh, yeah. Absolutely.
So that you can market your fluid for immersion.
And that's why I have immersion is emerging. That's better read as immersion is emerging at ExxonMobil. I do think, and again, thanking Copilot for putting me on the record here, but we are bullish immersion. I think at the edge here, when you push power consumption and all the billions being invested, and you think through hyperscalers, et cetera. I think DLC has a lot of headroom, and when we talk to folks, that's what I'm hearing is, immersion's too much of a pain in the butt versus the headroom available and the investments made on DLC, which I understand. But I think at the end of the day, when you're continuing to push and push and push, there's two responsibilities here. So there's the software folks, as Dan Stanzione mentioned on the keynote, optimizing and getting double ups on code performance. He's famously like anti-Python and anti-application almost, and just ribbing him a little bit. And then there's the facilities side, which is, we're not at 2x. There's not a way to get 2x better. You would know this given your career at HPE, et cetera. You can't get 2x, but we can get maybe 10 more percent, 20 more percent. And at the hyperscaler level, does that matter? Maybe it does. Especially if they're looking for ways to attract different customers due to cost, right? So if the cost is really that high, maybe 10% does help a little bit here and there over time, right? And so I'm bullish immersion for that reason. I think the end user, the mom and pop shop is going to be maybe challenged unless it's like a sealed unit thing that just kind of you don't have to touch, fill, worry about. And I like immersion for that. But other shops may not want to deal with oil as much. And so that's my opinion, not opinion of any company or anyone like that.
Well, maybe that'll be a jump in for Bill, because he is someone whose company makes it and he's using it. So, and I don't know if I don't know if we had a video link that didn't come through or something like that. No, I didn't get the URL. Unfortunately, I don't know how to. Maybe we can put it up at the end. But obviously,
It might be on the next slide, because I thought I saw it in the deck.
It was on there yesterday.
Yeah, I saw
It
it.
was?
in the deck
Okay.
This morning.
Or if you got a web browser, we can bring it up real quick.
Don't want to mess with the.
One of my concerns about immersion is the technology limit of what I would call static immersion. You know, when you get a really
I'm
dense
not an
rack,
Apple person, so if you
how
can
much
drive
can that,
to the
can it cool? Can
browser,
it cool
I don't know
a
if it's
200
bottom there.
kilowatt
Let's see,
rack?
it says-
Well, and you are kind
But
of
it's got
distributing out
it's a
your
little face-
footprint
little
too, so it's not the
Right.
power density isn't
Right.
the same because these racks are laid out horizontally, so more square footage. So
But the heat coming off a very small GPU is intense. And you get too many of those and it can't cool the whole thing with just convection. So now
Tank
people are going
innovations.
to basically adding DLC into it and just,
maybe while they're doing that, a question I didn't ask you, Tommy, about the
Yeah.
immersion tank. Are you seeing still the problem that used to be there with wicking of the fluids up the cables?
Yeah.
And then
oh yeah.
your sysadmins having to worry about wearing nice pants to work and having to change their pants from.
Yeah, it's still pretty messy to work on that fluid. And if you do get mineral oil in your shirt or anything and your wife does your laundry, make sure to tell her, please. Because they do need to put a little spot remover or whatever to make sure that that mineral oil comes out. It's a little, I know there's some discussion about warranty. One of the advantages on our purchase for Lone Star 6 with the immersion is Dell actually has a SKU that they'll sell you the servers and you can get the warranty through the SKU. But they don't want the DIMMs back. As we replace DIMMs, they just keep the DIMM. We don't want
Well,
it.
that's a good point, because I remember this when I was at HPE, and it wasn't us. It wasn't the server vendor. It was, the price of a server is because all of the equipment inside is warranted. Things
Mhm.
they fall out, and we send them back to the motherboard manufacturer, to the DIMM, to the power supply, and then they repair that and use it in their warranty pool. But the minute that they get it back and they go, what is this? I can't repurpose this to sell it to someone else. So, I mean, the way that it seems like that would be solved would be, there has to be a critical mass around it that says, hey, the DIMM failed, because DIMMs fail, and then DIMMs are expensive, or whatever is expensive, so it needs to be able to be returned to service once it's, people, you don't throw them away. Nothing ever gets thrown away in the industry, well, unless you have to
So
crush.
do DIMMs get repaired? You're educating me here, or do they just get?
DIMMs do get refurbished. Yes.
Everything potentially has the ability. We'll go back to the supplier. You would come to HP or Dell and say, "Hey, it's under warranty." We would turn around and go to the DIMM supplier. What they do with it then is up to them.
So from my experience here, we actually see and it's limited experience, I'll say it, and I want to defer to Bill, who runs it in production, as per your point earlier, but we actually do see a reliability increase in things that aren't power cycling a lot. And again, Tommy would have opinions as well, but so after you pass the qualification process, I'm skeptical that it's going to be a big deal. But getting through the qualification process where DIMM folks can feel comfortable that the oil didn't break their stuff, and maybe there's a more institutional knowledge around how to clean gear, or have it like processes around don't ship until it's cleaned, and kind of that type of thing, I think would mitigate a lot of that challenge.
We're good?
Yeah.
Okay. So I found out I was giving this talk a little bit too late to get slides. It's show we have to get our slides approved and blessed. This video is out on the web, so I can show a video. They say a picture's worth 1,000 words, and I heard 60-second video of 1.8 million words, so I think I'm doing good. Apologies to Tommy or anyone online who can't see this. I'm going to play this. I'm not sure how long. But yeah.
Yeah, the Skybox Data Center here in Houston. Matter of fact, those who are local, I think one of the societies is having an open house there in about 6 weeks. So if you haven't seen it, I encourage you to, Rachel was here yesterday, again, it's going to be open for something soon.
Yeah, Doug has their immersion right next door to our place. It's a really neat place to visit if you ever have a chance to visit. In the slide right before I start, you'll see, what is that, 6 of our GRC Duo tank. We actually have 8 now. There's 2 more in the space up here in front. Those racks behind there are DTC, direct-to-cooled chip racks, and then behind there we have air and networking and storage and tape.
This is the, with the, minus the difference in the wrap, is this what Lone Star 6 is, Tommy?
Basically, yeah.
The 4-pack?
Four pack, designed for, I think they designed those for 300, a little 300 kilowatts for the 4-pack.
For the 4-pack, okay.
Yeah, we chose the Duo. The Duo looked like it could do more kilowatts per tank.
That's true.
And maybe that was our generation or whatnot. So they're rated at 100 kilowatts per tank. I think we spec'd it to about 92. We're actually getting closer to 70, 68. It's one, 2 tank for 1 CDU, which was nice. Each CDU connection in our facilities cost a lot to connect, so that worked out well. And another thing about the Duo is if they have a lot of dry space, roughly 8 U of dry space per tank, to put networking gear, put another PDU in place, or whatnot. But you do need to make room. We don't have that center space that Tommy mentioned for theirs, where you run the cabling down. Maybe we just didn't have it connected the same way, but GRC did all that. So, but you do need space for cabling to get down, and we'll get into that.
And did you have to mount your switches right side up versus upside down?
Yeah, so I think we were the benefit of Tommy and his team learning that. So Penguin did our integration. They told us, yes, these Mellanox 100 gig switches, and in HDR InfiniBand, yeah, you got to mount them port down, which is real pain when you're trying to see if the link lights are on or whatnot.
They need to come with shoe mirrors
No.
so you can see.
Yeah, that's a good idea. I don't think we did that. The 1 gig switches, they can go straight up. They're just fine. We actually did some NDR 800 gig switches from Mellanox, and I'm told they can't even be vertical. They've got to be in a rack, horizontal.
Yeah, the new switches all have to be horizontal.
Yep. So, yeah, so touching on that, we actually did have to put a rack a little bit away from an immersion tank and running optical. So optical is the thing you don't do with immersion generally. Definitely not a transceiver and a plug-in cable. There are vendors that do AOCs that are certified for immersion. I think we use America for this. You go to supercomputing, you'll see plenty of vendors talking about it. Sometimes you have to reseat those cables quite a bit. But
So the MPO, the single mode or multi-mode optical fiber, where it mates in is
you don't want
it's the index of refraction does not degrade the signal integrity of the.
No, the AOCs are sealed.
Yeah.
Okay, sealed. Okay,
right. You don't want a transceiver in the MPO.
okay.
I'm going to play this.
Because again, the light works because the index refraction of air, and as the 2 ends push together.
Right. This is the deployment of our first 6 GRC Duos, so that's roughly 12 tanks worth. We actually deployed these half 1 month and half a month later from we lease all our compute. I'll get into that in a minute. It took roughly 6 weeks to actually do the facilities while we're waiting for the equipment to arrive. Then we got the tanks in, and then the servers dipped into the tanks. Let me play this. Hopefully it's not too loud and I can talk over it, but we'll see. And again, apologies for anyone online who might not be able to see it. This is the preparation underfloor primary fluid network. The whole room has a water pipe going around, so it's connected at both ends. If you have to shut one down, you still have water coming from the other end. We've got the tanks arriving in back being set up. You'll see really quickly all the compute nodes will be dunked in and cabled up in just a second. There you go on the right. Got the PDUs along the back wall.
And you have a portable crane there that you're using to pull the chassis in and out?
By this point, everything's already installed from a system perspective. We're just doing the wraps, finishing up some nice and clean look on the tanks.
You didn't have the background air-cooled
No.
Xboxes.
Yeah, I'll touch on that real quick. It's really hard to measure PUE when you have a mixed environment. So we still have our air chill. This is a closed loop environment. So our water loop is all chilled with the same water that goes from the air handlers that do the air cooling. It's not the evaporative type. We don't want to waste water. Why waste energy and then just turn around and waste water? So we're kind of in the middle there. We do still have the water chillers running. They also have to support the air capacity. If you could split these up into different rooms and different systems, you can better measure the PUE. We definitely do see a better, lower cost on our electric bill since we got these in. Where are my notes? All right, so trying to get to the facilities lessons learned. We've had direct-to-chip in for 3 years now. We have just returned our first direct-to-chip deployment. When they brought it in, there was a little adapter added to the manifold. So the manifold on the back of each rack, and it connects to all the machine. There's an adapter at the bottom of that connects to a flexible pipe that goes to your secondary fluid network. When you're returning these, you gotta disconnect it. It disconnects pretty easily, but that little connector was sticking down beneath the floor tile. Once you do that, you've got to kind of figure out how to disconnect that or get the fluid out of the manifold. We had to, because we lease these things, we have to get these back to the leasing company pretty quick. So we shut them down, wipe the systems, and normally just roll out an air-cooled rack. But then we run into these extra issues that cause delay, and we got to figure out how to quickly get these addressed so they can get loaded up to the shipping truck and not cause any extra monthly lease and rents and so forth. So that was one issue. Really figure out what you're going to do when you're actually decommissioning these things. There's some extra steps involved. Plan everything out a good month ahead of time. The which ones? Yes. That's going to be point 3.
Is Penguin covers that, or is that through another party?
We do the procurement through Penguin. We get the quote, send it to a leasing company. They give us the lease quote. We choose whether to purchase or lease. We generally do a 3-year lease on our equipment. So that's another wrinkle when you get to immersion. I'll get to that in a minute. Installation and operating the compute pods. So onto immersion, we do have oil that is really certified for 8 to 10 years. We manufacture this oil. They're going to be focusing on direct-to-chip secondary fluid as well pretty soon, but right now we're into immersion. You really want systems that are designed for immersion. So these that you saw in the video are our 2nd generation immersion. We had an initial pilot over in Europe. We got systems, worked with the vendor. They were air-cooled systems. We took off fans, changed BIOSes, adapted them for immersion. It's really important that your materials that the servers are made of are immersion friendly. There's a big immersion material compatibility process that we've gone through with the vendors on some of our newer deployments, just to make sure different parts absorb more oil over a month, over 6 months than others. So that's a big piece. We had a vendor that was going to come and have us try a trial system in one of our tanks in that extra room. The server was not made for immersion. The power and network are on the bottom when you put it into the tank, and you've got to worry about the different thermal paste, different types of heat sinks on the processor. It's a big deal. So make sure when you are working with a vendor that they have a system that is made for liquid cooling. We work with Penguin. They work with Gigabyte. We've had some good results on our systems. We talked about the network switch orientation. With the GRC dual tanks, they want you to even the load out across both tanks because you have one CDU cooling both sides at the same time. For our seismic, that's not a problem. They're all running full blast. We have a couple of others that are not as heavily loaded. With Slurm, they schedule jobs across identical machines alphabetically. You can do things to get around that, but we would see one tank was kind of running, the other was pretty cold. So you can work with weights on the Slurm configuration to spread that out. We haven't done too much of that. Like you said, let's aim for the 5 times increase in the software and not worry about the 10% power, but who knows. Took a look at three-phase power while we're at that as well. We're reading the power to determine what's used. Make sure your power is balanced. Sometimes you'll have these deployments and they'll be out of phase. If you need to learn more about it, just take a look. Sometimes we'll have one tank that looks great, another guy plugged in the other one. It looks pretty to him, but you'll have a 54% out of phase power PDUs. I won't go into it too much. It's getting into the weeds. My final point, planning the return of our first immersion compute pod. So yeah, we lease our capacity. The leasing companies really don't know what we're doing. They don't know what they're getting back. They're expecting to get back a node that they can take around, sell to someone else in a cooled, air-cooled rack and whatnot. You know, you work with them ahead of time. It's 4 years later, and then there's someone different working there, someone different working at our place.
But shouldn't it just be the tank? I mean, you're not going to put other servers into that tank. The tank is a percentage of the cost. Don't you just want to return the whole thing to a leasing company?
You can. The tanks are good for 10 years from GRC.
Your oil's good for 10
Oil's good for, so assuming we still have the same compute capacity, we will continue to keep these tanks. You're not going to ship the servers back in the tank. The tank's going to be decommissioned.
Okay.
So it's not like a rack. So we would likely keep the tank if we kept on doing immersion in the tanks. About warranty, our compute warranted. Penguin sells us our stuff. They handle that warranty. It's great. GPUs, you need to check to see if you have a warranty. Your integrator like Penguin might warranty that on your behalf, but NVIDIA not going to sign up to do that. So check and make sure if you're going to dunk something, make sure it's got a warranty, or you're willing to live without it if there are issues. We've never had any issues. We've got some GPUs in oil. They've been going pretty well. So
it's well, what I heard was that if someone wants to try it, he might tell you a leasing company who's going to make a great deal on some slightly used, but they've been in Shell oil, so you know that they're pretty good. And they're second generations. If you want to try it, there might be a leasing company who's got some coming.
Our only other part is when you return these, you generally lift the system out of oil. I don't know if you saw there's a black gantry crane that we use to actually lift the systems out. That's great for day-to-day operations, but if you're going to go ahead and return all 72 nodes in one tank at once, you're lifting it out and you're letting it dry and you're sitting there for 30 minutes or so before you move to the next one. So you may have to drain the tank completely, let them dry in there, and if you're keeping the tank, bring the oil back after they're out. So we're got to figure that out. We've got another year on those tanks you saw there, but we're working on our first one in Amsterdam that's coming up at the end of May. So it's a learning process.
Do you really think the tanks will have the capacity to deal with new equipment?
So GRC rated each tank to 100 kilowatts, but they said depending on your water temperature and your flow, you can actually do quite a bit more. So work with whichever tank you're using to figure out what you can do. You don't have to fully fill a tank, but yeah, we'll see. Yeah, I don't know. If you're looking at large GPU systems that cost a lot of money, maybe you look at direct-to-chip, maybe not. I don't want to ding on immersion. There are changes. The AMD CPU has a 360-watt TDP by default on our system, but we can crank that up to 400 on the immersions. We've done it for 4 nodes, but not the whole thing. So that's something we want to look at as well.
Can you speak on reliability related?
Yes. So in Amsterdam, on our first one, once it was all stable and going, we had much better hardware failure rates, lower rates. In Houston, we've seen about the same so far. That system's been in for about a year and a half. Not worse, but not necessarily better. So still trying to figure that one out.
You joked about, NVIDIA support, but I think he could, each company that makes servers that is interested in it, would come to us and we work with them. I think I said it last year, right? And so, we don't sell it in our DGX brand. Our DGX brand is, the exemplar for the high performance software, and it's a certain amount of configurations. And I mean, we didn't even do the original one, DGX, with cold plates. It was only air cooled. But for the OEM partners that we have, Gigabyte, Supermicro, Inventec, Foxconn, all of them, that we help support them where they have large immersion projects.
Well, and I think we're further along because of the fact that we're even hearing a server that's designed to go in liquid. I mean, 10 years ago, there was no concept. I mean, people were buying super micros, taking fans out. Is there anyone from CGG in the room? Or a former CGG person? Yeah, so I mean, they were pioneering that and deploying that at scale, before people were really
And
talking about it.
It was
So
Rolf at Asparagus when he was with Uptime. He said otherwise known as the dunk and pray method. You just hope.
and that's where I mentioned the comment about
you
wicking
hope that it
because
works.
I remember the sandbags behind those racks to catch all the drips that would wick up the gigabit cables and drip on the floor in the back. So I think we've come a long way, and I mean, manufacturers are going to support it if they see more
they see
adoption. But these one-offs or testing scale, yeah, it's hard to get to say everyone's going to support it. But I would like to talk to you offline about your leasing company.
And there's Donnie. So Donnie prepared so much. Thanks.
We'll return the gear first, and then yeah, that's fine.
Yeah.
So I did shamefully steal some slides from myself from last year. I feel a little sad now. I should have just thrown up bullets because I don't feel like I'm a sysadmin anymore since I spend so much time in PowerPoints and spreadsheets, but I'll do my best. So these are our two swim lanes. So we're a little bit different than the other folks up here. We're split. So Total Energy's HPC is really, whoops, that's not the right one. So in Houston, we focus on these two swim lanes, R&D for HPC, HPC for R&D. So what that means is we're prospecting and scouting technologies and testing a whole gamut. So we're not really doing the at scale. We're more in the megawatt, sub-megawatt range. We're deploying initial rack scale for proofs of concepts and testing. And then as we start to scale up to the rack scale, then we support getting our domain scientists onto our machines where they can prototype and start to test their science. And then we sort of have a connection with production because that's the one I don't list up here. So we don't do production in Houston. It's all done in France. So our large facility is in South France on the Pyrenees Mountains. In Houston and in France, we've been doing DLC since about 2012. We both deployed some ICE X machines in Houston and in France, so that was our first experience with DLC and working with water in the data center. So when Wade asked me about learnings from last year, this was also a slide from last year. I put that, rest in peace, poor CPU. You did a great job of driving our energy, our power envelope up late in your life, but you can't kill economy of scale technology. So the reason I put this up is because in 2019, Total Energy shifted all towards accelerator technology for production. And in Houston, we were already on pure accelerator technology other than the CPU cores that were in the host. And then we also started testing like the Fujitsu ARM technology when it came out back in 2020. A good platform. So in Houston, we're always trying to think about what's next. And we weren't seeing a lot of innovation in the CPU market. I know we have HBM. It'd be interesting to talk to anyone that's started any work with the MR DIMMs to kind of see what you're seeing there. But last year, we started getting a lot more applications coming into our environment out of the open source and out of some of the DOE labs, and not all that code is ready for accelerators. So we had to kind of split our HPC procurement last year in Houston and bring some CPU capacity back in where we had pushed it pretty much all out in 2017. So the lesson learned from last year, we did anticipate it, and now we need kind of more of it. So now we're kind of stuck with bifurcating our budget because we still have to deploy what's next. And bringing in CPU capacity for the researchers is a little bit challenging for us right now. This is sort of how we're laid out. This is how we move things through our sort of roadmap and our strategy. Kind of Houston's on the left and France is on the right. And in the middle is where we meet. And in the middle is where we sort of have the most challenge for scaling up some of the CPU codes that are coming in out of the open source or things like that. But like most of these guys, pure seismic and even on reservoir, a ton of GPU usage. We've been in production on seismic since 2019 for GPUs.
Donnie, can you share how many people you have in the R&D for HPC kind of area, maybe?
So we have around 3 sysadmins in Houston, and then we have, one kind of software stack builder. He builds the development in the modules environment and works with sort of the HPC team that's helping build applications, which is another couple of people. We have like a benchmarker. So our department is maybe 10 to 15 people in Houston that's focused purely on HPC and the topics surrounding it. And we have people doing numerical methods and uncertainty quantification and things that are more out on the research side, but operationally, my team is really 3-4 staff and a couple of contractors, and then some consulting with a team I have that I call the Space Cowboys. They're the old Fortran guys that we just throw them a project and they deliver results. So we don't bog them down in the day-to-day. They're just old school HPC guys that know how to port, tune, and optimize software. So that's what they focus on. This is what I already talked about. So we're also leasing in Houston. In France, it's a little different model because of the way taxation and things are done around lease versus CapEx. But in Houston, we moved in 2017 away from CapEx. And part of the reason was to acquire and remove the technology in Houston at a more rapid rate. And with our dear friends over here aiming to drop a new technology per year, we didn't want to keep things for even 36 months. So last year we moved to a 24-month full market value lease. And it's pretty flexible. You find a good leasing company, you can really work with them on your end of lease options and things like that. So you can either return the equipment, you can do dollar buyouts, you can return part of the equipment, or you can just ship it all back. And we've done all of those things. We've kept equipment, we've bought equipment, and then we've returned equipment. But I haven't returned any equipment that I've submersed in oil. So I want to know how that works. So from a facilities perspective, in Houston, unfortunately, we're in about one of the worst buildings that you would ever want to stick a data center inside. I see 2 of my colleagues out shaking their head in the audience because we put a data center inside of a downtown building that was built in 1973. We don't have a raised dock. We have a freight elevator that sinks down about 3 inches when you stick a 2,500-pound rack in it. So you have to be very good at, and our data center's on the 2nd floor, so not a building that I would have put a data center in, but I did sort of inherit that when I came on board years ago. And we are always constantly looking because we lease the building. So we get dual power feeds, so we didn't put a generator, or we're just backed by UPS in the HPC facility, and we're at the mercy sometimes of the building. And when they do maintenance on these big bus bars that go up each side of the high rise, these big 4,000 amp buses that are tenant power, and there's breakers. I don't even think there's breaker space left on this thing, but we've stuck breakers just about everywhere you can stick one. And they did make buildings very, very capable though in the 70s. If you think about it, I mean, we've got several megawatts of computer power in this building that I guess was overbuilt for back then. The fact that we can do it. So we ended up with a dual MEP room that got power from both sides for our DLC deployment. So what we did last year to try to avoid these cycles where they work on a bus and it would impact us is we put in these static transfer switches so that we can put those in front of our main transformers that's feeding at least our 208 volt power in the roof. We still have 480 under the floor, which would not be redundant, but the main power feed, we put these transfer switches in last year. And we were really excited about the first time they were going to do maintenance in the building. And then January this year, they announced they were going to take both buses down. So
Beat that.
yep. So again, like I said, we have these 2 swim lanes. We do, you may ask, why not cloud, especially if we're leasing? I kind of lost my argument or something I used to say when people ask me about cloud, especially upper management, and I just say it's just somebody else's computers. I mean, there's nothing magical about it. Of course, they have a software ecosystem and an environment that, you can work inside for different types of applications that we may not host on-prem, but it really is just somebody else's computers. But then when I started leasing, I guess I had to rethink
You heard
that
it,
because
it's
That's
someone
right.
else's
because
computer.
I'm deploying somebody else's computers.
I still own computers for anyone who is interested in that.
But we've done the MVPs and large scale tests, and I mean for 6-7 years out in cloud, and we always compare the ROI and testing. And in production, you can go out and search Pangea 4. There is a hybrid system, so we usually in production have two production systems. One is typically dominated by seismic, the other one is reservoir, and then a mixture of applications on both of those. But Pangea 4 deployed last year in France, so we're running Pangea 3 and Pangea 4 now. And P4 is a hybrid system, so you can go look at sort of the specs. I don't know if they put the capacity out there, but it is a on-prem with a cloud component. Whether or not we keep doing that, that'll be up to how they see the financial operations running and what the actual costs were for running it. It was sort of that, let's test it in production, because we've been testing it in research for years, and the results are always the same. I mean, the driver on cost is how much you're charged by the cloud provider.
How big is what technology, and how big is Pangea 4?
Not sure if they've published the size of it, but it's a Cray system. This is a Genoa-based CPU system on-prem. And as far as the capacity in cloud, I don't know if they've publicly said how many cores we have.
Liquid
it's an
cooled,
EX?
liquid hybrid?
Yeah, it's DLC liquid.
Liquid-
It's-
okay.
EX or XD? Okay, thanks.
So I think that's all. Yep, that's all I have.
Well, I've got a few that I think will, I mean, again, we started a little bit late, but I had a few pictures more than words that I learned. And the first thing was, when I went over to NVIDIA, the last thing I had designed was this great HPC system that was hybrid liquid cooled for HPE for France, a customer in France. And I came over, and what I saw that NVIDIA was doing was they were really heavily invested in the OCP ORv3 rack. And, for those people who had seen it since the Facebook days, the Freedom Rack, the triple, it was a 7 kilowatt rack, and the bus bars and all of that. But NVIDIA really doubled that. Matter of fact, we released at OCP this year our own version of it called MGX, because everything we have has got a GX in the end of it. But it's amazing what this thing is capable of. We went up from 30 amp cords to 60 amp cords. All the power supply vendors now, all of the power supply vendors, not just one or two, are looking at building it with 100 amp cords. And so these are pictures from GTC last year, so I can show these without getting in trouble. It's got a place for 2 cords on it. Right now it's 1, but it could go back to 2 cords. There are 8 power shells. And so what you're looking at is our racks have 276 kilowatts of capability in it in a 4 to make 3, or actually 8 to make 6, because it's 8 power shelves. And so that's 207 kilowatts one end, and then the cords and everything else is going to increase that. With the 100 amp cord, it goes up to 345 kilowatts, but in theory, a pair of 60 amp cords would allow resilient over 400 kilowatts in any one rack. Now, it can't be air-cooled. And so at the back of the rack, then you see the manifolds that have all the quick disconnects for liquid cooling in it. And so if you haven't studied it, again, I wasn't following it, but go look at the rack. It is quite capable. And the cool thing now is, because this stuff is taken off, it's not just something that you're going to get for the hyperscalers. Supermicro, Dell, HPE, Lenovo, everybody has one. So if you're trying to look at, right now it might only be our NVL72 in it, but I have a perception that there'll be some Gaudis in it for somebody. Gaudi, is that what they still call the Intel one? I look at you like from 10 years ago or whatever. It'll be some AMD in it. It'll be CPU based. It is a very resilient, easily moved, high volume, which means low cost because it's everywhere from a delivery of power and cooling. So that's kind of my first bullet is I would encourage people to go study that rack. Well, DLC plus whatever residual for the remaining cooling. That residual could be 30%, that residual could be 0%, well, probably at least 2 because you don't want to melt the skins of it. But yes, there will be some residual cooling technology. Oh, what happened there? Did it jump up too far? Let me go back up. So we do the 3D modeling, all of it, and what I wanted to show you there was the 4 racks in the middle, and it's a little blurred on the screen here because of the color, but the 4 racks in the middle are the GPU racks, and there are 8 power cords for it. And I spent a lot of time in the last 15 years putting busway in because of flexibility. Well, this is an Equinix data center that was made for 6 kilowatt racks, and it's only 15 feet. So and we had to get them to get water in, and we had to get networking in. But this is literally 1.5 megawatts in these 576 GPUs. And we have the circuit breakers and the row power panel. But the electricians loved it. I didn't have to wait in line for busway. So I kind of fell in love with tray cable and junction boxes, which I never would have thought I would, because I'm just so used to busways, and I like the breaker. I can access it. But and we've been hearing this. The folks at Abilene building Stargate have said the same thing. A bunch of people building at scale saying, this is just easy. And so I hadn't thought about it that way before. And I talk about future-proofing. So actually, I'm probably not authorized to show these, but I'm showing them anyway. This is from my lab/data center. And so, we got some cool colors on the back of the rack. Usually Jensen shows those where he's carrying around the 5 miles of cables at the back of the rack. But what you see here is, look at the 8 power cords in it. And as power goes up, you can see that if I had to double the power density, I could just borrow the extra 8 cords for the other, and it would fit in it. And remember, I showed you on the other picture, the other side of the rack has room for a second power cord because it actually was developed that way. So I mean, this is what's in my my lab/data center right now. And so saying that, look, I can, and this is an Equinix. This was a 6 kilowatt a rack data center. And I was able to put a rack that is 500 kilowatts capable in it. Now, granted, the whole rest of the building is empty. Yeah. So if you want to release some pickleball court space, or rack, or skating rinks or whatever, man, there's a lot of empty space in there. But it's literally a caged colo. So the other thing is water control. Water control is evolving, and so these are the water taps for 4 effectively 200 kilowatt racks. Now, here's a supply chain. It's not a funny story, it's a sad story. I have 2 supplies and 2 returns for each rack, not to feed 2 manifolds, but the FD83 connector, which is a hot plug connector with a valve already into it. There was a worldwide supply shortage because of people buying GPUs, and I couldn't get 2-inch connectors. So literally, I had to go build a whole bunch of data centers around the world with 2 1-inch connections, and then wire it out. But that's what's happening with large language model building. You make do. You don't sit around waiting for something. You go figure out a different way to get there. But you can see the Belimo energy control valves, the multiple valves. The first thing is, if you ever did have a leak, you want to be able to detect it with a rope sensor in your building management system, and so that you don't short out your IT. You want the valves to close so that you don't have continuous flow of water if you had a leak. The other reason is that now when I've got a CDU that's feeding multiple racks, I'm going to have different flow and impedance over time. And so either it's a DP or a DT control, that energy control valve opens and closes for the flow rate. So that way, it's not that you're not wasting pumping power, because pumping power is small, but it's that you want to make sure that you get the right flow at equivalent pressure drop. Because in theory, somebody could design a future rack and plug it in that has very low impedance and much lower power, and literally it would steal all your water. I mean, I can't make it go to my rack. And so what the valves do is allow flexible systems runtime, right? So some rack might only be running at 20 kilowatts, the other's running at 200, and so the one that's running at 20, the valve closes down. And so that's something that we're evolving over time. We've donated this hydronic specification to the industry, and we're looking at having, multiple vendors, Cool IT, Motivair, Vertiv, and others be able to build this. So as you get into liquid cooling, the hydronic controls matter for both safety and energy balance. So make sure your hot aisle is wide enough. When somebody says, oh, this rack is 1,200 millimeters deep, did you account for the bend radius of the power cord and the hoses coming out and accessing them? And again, this just happened to be an Equinix Colo, and we couldn't dictate the water manifold overhead because they had already got it blessed by the city before they met us, and so there were some challenges there. But I mean, we're doing this at scale in a caged colo so that we know it can be done everywhere. And then finally, I think it's my last picture here. Commissioning is very important, and so we have a digital twin of everything. And so, for whatever reason, we decided to ship it all dry. Well, no, I'll be very clear. We shipped it dry because we sell to Google, who likes to make their own water, and we sell to Lenovo, who likes to make their own water. We would prefer, the industry would prefer that it's always energized with PGW 25, and then you just top it off, because it can ship to hot climates, it can ship to cold climates. You know that you don't have any bio-growth because you can control, if Tommy was still on, if he said that you can control the pH and the chemistry of it, but some people decided they want to energize with their own fluid. 16 barrels of PGW 25 and quite a few different implements for pumping and filling and pressurizing. It can be done. We've done it. We've written a commissioning recipe for it that we'll share with the industry, but you got to commission it, right? You don't, only Elon has enough money to commission his 100 megawatt data center with his $7 million racks. Most people don't want to use their $7 million rack. I'd give these guys a discount. It wouldn't be $7 million for you, but they don't want to commission their data center with their very expensive load, and so you got to make sure that you get in advance, make sure that your flow control valves work, that your power distribution works. It seems silly to say don't forget about commissioning, but we've seen people taking shortcuts there. So that was all that I had to share, just a few images of it. I figured we'd be talking about it throughout the day. Did you guys see my pictures beforehand? I don't know, they were to surprise you with them. Yeah. So surprise these guys with it today. Wait, what is that? Go back up to that one. What's it?
I think we're,
If we're closing out, I just need to say one more thing on behalf of my team and my senior principal. And if you're a passionate admin, dev, you want to expand your horizons a little bit and engage with other passionate folks managing systems, we are hiring. So we're just got to throw that pitch out. You showed all your cool pictures. I'm trying to bring back to the community too. So hit me up, or Raj Gautam, or Alan Wild, or Andy back there, or Ronaldo, if you are interested. Thank you.
and for anyone in my team that's in the room right now, don't think about it. Just
No friendly fire, Donnie.
and
no
I'm
friendly
making
fire.
my way around the room here.
Total spent their hiring budget for the whole year, bringing in some big talent.
Yeah, exactly.
So you probably.
Bring them out of retirement.
Okay, well, thank you. I know we started a little bit late. We went a little bit longer, but I want to thank the panels and Tommy. And we're always available for feedback. You can tell most of us are pretty excited about what we do around here, and we want to share that excitement with everybody.
Thank you.
Thanks, everybody. Thanks, Mike. Have a good one.